Okay, so let's do some end behavior. First term is negative and it has an even power, so it's going to look like that. That's going to be down, down. Next one is positive and odd, so it's going to start low and high, so it's going to be down, up. This one is positive and even, so it's going to be up, up. And this one is negative and odd, that's going to start high and low, so it's going to be up, down. Okay, let's get to long division here. So we're going to set it up. 2x minus 1. So what we're dividing by in the dividend would be 4x to the fourth minus 4x cubed minus 5x squared. Wow, that's a long one. Minus 9x minus 1. Okay, so let's see. The first term would be 2 times 2 is 4, so I know it's 2, and then x times x to the third, so 2x to the third. I'm going to put that in the x to the third column there. Multiply by negative 1 also, so negative 1 times that is minus 2x to the third. I'm going to subtract both those guys, which means I'm going to distribute that negative and make that positive, so I'm adding there. So I get negative 2x to the third minus 5x squared. So 2x times negative x squared, so negative x squared goes up here, is that. Negative 1 times that is plus x squared, but of course we're subtracting everything in that row, which means boom, boom, change every sign. It's going to be a negative there, so negative 5 minus x, not minus negative 1, x squared is negative 6x squared. Bring down the next term. 2 times negative 3, so negative 3x would be the next term. Negative 1 times negative 3 is plus 3x, but of course we're subtracting everything in that row, which means we're changing the signs. So we're subtracting, so we get negative 12x minus 1. And this would be minus 6. I know I'm done up there once I get that, because that's a constant. Negative 1 times negative 6 is plus 6, but of course we're subtracting everything in that row. So changing the signs, you get negative 7 as the remainder. So your answer is this plus the remainder, which is negative 7, divided by the divisor, which is 2x minus 1. The quotient is the remainder divided by the divisor. These are just pretty tough ones here. So I've got, just get a lot to them, x squared minus x plus 1. And we got x to the fifth minus x to the fourth plus x cubed minus x squared plus x minus 1. It doesn't have a lot of coefficients, so that should make it a little easier. X squared times x, what is x to the fifth? That would be x to the third. So we get x to the fifth minus x to the fourth plus x to the third. You're going to subtract everything, which means change the sign of that, change the sign of that, change the sign of that. Well, this is interesting. That goes away. That goes away. That goes away. Wow, that's crazy. Okay, so that was unexpected, but it can happen. So x squared times what is negative x squared? Well, that's just minus 1. I think I'm done up there. So I'm going to bring down all those terms essentially. So negative x squared plus x minus 1. So x squared times negative 1 is negative x squared plus x minus 1. We have to subtract that though, so everything changes sign. Everything goes away. The remainder is 0. So my answer is x cubed minus 1 is my quotient, and there is no remainder. Pretty cool problem, the way that worked. So now these are simpler. You can tell it's just x plus or minus an integer there. And so we're going to use synthetic division, right? So the key thing, this one of the keys, is definitely, if x minus 3 is the factor, 3 would be the potential solution. So it's the opposite of what the factor is there. This minus 3, this is going to be positive 3. So make sure we're going down by ones. We are. There's no break here. So 2, negative 4, negative 7, and 5. Bring down the first term. 3 times 2 is 6. Adding vertically. 2 times 3 is 6. Add vertically. You get negative 3, which is 2, remainder 2. This is x squared, because it goes constant, x squared, and that's the remainder. I guess there's that. So if you want to give the final answer, it would be the quotient 2x squared plus 2x minus 1 plus the remainder of 2 divided by the divisor of x minus 3. In the box, this is the most important step probably, so negative 2 goes in the box because the factor is x plus 2. Coefficient, ooh, this is important, so 1, negative 2. I'm missing a 0, I'm missing like an x squared term, so I'm putting a 0 in there, and then 13, negative 6. Okay, synthetic divisions, you get 1, negative 2 times 1 is negative 2, you get negative 4. Negative 2 times negative 4 is positive 8. Negative 2 times 8 is negative 16. Okay, that's negative 3. That's positive 6. Oh, this works out beautifully, right? So remainder is 0. So my answer, this is going to be x squared, x cubed. My answer is x cubed minus 4x squared plus 8x minus 3. So we're using synthetic division again. This time we don't take the opposite. In the box, it's going to go negative 2. The key thing here is this is using the remainder theorem. So on the front end, you're thinking, okay, I'm using the remainder theorem. The answer is going to be my remainder. So 1, negative 1, 1, negative 1, 1. Wow. Okay, so 1, this is negative 2, negative 3, 6, 7, negative 14, negative 15, positive 30, 31. So my answer is 31. In other words, the question was, what is P of negative 2? The answer is 31. The answer is the remainder when you do synthetic substitution. Use a factor theorem to determine whether the binomial is a factor. Okay, I'm just going to do synthetic division, but this time it's a factor, so what do I put in the box? I put positive 4 in the box because that's a factor. This is going to be 1, negative 5, negative 2, negative 8. If I get a remainder 0, it's a factor. So let's do, you're adding, get negative 1, negative 4, negative 6. Let me just make sure 1. Yeah, negative 1, okay. Negative 4, negative 6, negative 24, negative 32. That is not a factor. Boy, it just really helps to be good at synthetic division here. They give me the solution, not the factor, so I'm just going to put the negative 5 in the box. I don't have to take its opposite. 1, 1, negative 15, and 25. So they basically told me this is a solution, so I should get a remainder 0. If I don't, I'll just kind of check my work because I should. Negative 5, negative 4. This is positive 20, positive 5, negative 25, and 0. Okay, remainder 0. So this is a quadratic. That's x and x squared. So once you get to the quadratic there, we know how to solve a quadratic, right? So hopefully this will factor. If not, we'll use quadratic formula. So x squared minus 4x plus 5 equals 0. So we're trying to solve that. Factors of 5 that add up to negative 4. Oof. They both have to be negative. That would add up to negative 6. I don't think it factors. So we're going to have to just do quadratic formula. So x equals, the opposite b would be 4 over 2 times 1, because a is 1, plus or minus. B squared would be 16 minus 4 times 1 times 5. So this is going to be 2 plus or minus 16 minus 20 is negative 4. So square root of negative 4 over 2. This is 2 plus or minus, that's really 2i over 2. The 2's cancel, so you get 2 plus or minus I. Those are 2 of my answers, and then we already were given our other answers. So there are 3 solutions, which makes sense. This is x to the 3rd power. We have 3 solutions. 4th degree is always a little bit tougher here. So we're going to take out one of them, and then the other one. Let's take out the negative 1 first. So negative 1. By the way, I just checked, and this should say x equals 3 and x equals -1 as your two solutions. I think I changed the problem to make it easier, which is appropriate in this case. Okay, so 1, -2, -5, 4, and 6. So what should happen, I should get a remainder of 0, right? So if I don't, like, you kind of know you made a mistake. 3, -2, 2, 6, -6, 0. Okay. So once you get 0, we took -1 out. So now I like to put this box right there, draw the line right up until the remainder line, and do synthetic division again on my answer now. So 3. So when you have fourth power, you're expecting two nice rational roots. The other two roots are probably going to be imaginary or irrational, something not very nice. Okay, so 1, this is going to be 3. Okay, 0, 0, -2, -6. That's nice. Okay, so I get a remainder of 0. This is x. This is x squared. So I get x squared minus 2 equals 0 as my other factor. So if you could factor this, but really this one, if you just move the 2 over, we can probably solve this. We've done problems like this. So add 2 to both sides, so equals 2. Really all you should do is take the square root of both sides. Don't forget plus or minus, so x equals plus or minus square root of 2. So you really have 4 answers there. You have these two that were given to us, and then we found the 2 irrational answers by doing some synthetic division here. Find a cubic equation with integral coefficients as the given numbers as a root. So cubic means third power. And this is an extra credit question this year because we didn't get to this. I'm going to send out a short video about this, but this is how to do it. You know, because of the complex conjugates rule, there's got to be another imaginary. And the complex conjugate rule says this: if one of them's a plus bi, the other one is a minus bi. So if one solution is 3i, the other solution would be -3i. So now you know our three solutions. So you can write our three factors. So y equals, it's always just x minus the solution. So x minus 2, x minus 3i, and x plus 3i. And I think what's going to happen here, if I FOIL these guys together, it should work out pretty. Okay, so if I FOIL it, well, it's difference of squares, so I really don't have to do first and last. So x squared minus 9i squared times x minus 2. But that actually simplifies further because that'd be x squared plus 9. Because remember, I squared is -1. So now I'm going to FOIL those two guys together. So I get x to the third minus 2x squared plus 9x minus 18. And that would be my polynomial in standard form. We want to just list the possible rational zeros. So you take the constant here, factors of 10 in the numerator. So we're going to go, okay, factors of 10, 1 and 10. Actually, all those are plus or minus. 2 and 5. I think that's it. Factors of 2 in the denominator, so plus or minus 1, plus or minus 2. You're doing every possible fraction. So I'm going to do all these over 1 first. So 1 over 1 is 1. 10 over 1 is 10. 2 over 1 is 2, plus or minus 2. 5 over 1 is 5, plus or minus 5. So all those are over 1. We've taken care of that. Now let's take care of the 2 here. So it'd be, first one will be plus or minus 1/2, plus or minus 10 halves, which is 5. We already have that. Already got that taken care of. Plus or minus 1, we already have that. And then plus or minus 5 halves, we don't have. So those are the list of all the possibles. Same thing here, factors of 6 on top, so 1 and 6, 2 and 3. Again, all of these are plus or minus, plus or minus, plus or minus, plus or minus. Factors of the first term in the denominator, so 1 and 5, or plus or minus, plus or minus. Okay, so all the ones over 1 first, so plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. Now we do out of 5, so denominator 5 would be plus or minus 1/5, plus or minus 6/5, plus or minus 2/5, and plus or minus 3/5. Doesn't have to be in that order, but you got it. Find all the solutions by factoring. So let's factor this. So it should be a difference of cubes here. So x minus 3 times x squared plus 3x plus 9 equals 0. So one solution is x equals 3. Got one. This one doesn't factor. It almost does, but it doesn't. So you got to use quadratic formula. So let's do that. So x equals, the opposite of v would be opposite 3 over 2 times 1. Plus or minus square root of 3 squared, which is 9, minus 4 times 1 times 9, all over 2. So we get negative 3 halves plus or minus 9 minus 36 is 27, right? Negative 27 when you do that. Okay, so you get negative 27, so that'd be I root 27 over 2. Those are your other two answers. So we have 3 answers to that one. Find the solutions by graphing in your TI Inspire. Okay, so we're going to graph this. So 3x squared minus 6x squared plus 6x. There we go. And we're going to go menu 5, 1, trace, and find the x-intercepts. That's one of them. The other one is right there. I'm going to move that over. So we've got, oops, drag that. Oh, it doesn't work. Drag over. Okay, so 0 and 2 are our solutions, right? Those are the x values of the solution. So x equals 0 and x equals 2. The graph of it looked kind of like this. X equals 0 and x equals 2. Use your TI Inspire to graph and find the rational zeros. So I just want you to find the rational zeros here. So this one would be x to the third minus 4x squared plus 9x minus 36. 4. It wouldn't be a bad idea to list out all the possibles, factors of 36 divided by 1. You could look, if you're not sure, not real sure, I could always zoom out, menu, window zoom, just want to show you you can do this, zoom out, and just see if there's any other zeros, because 36 technically could be a 0 there, or some factor of 36, but I don't see it, so you're good on that one. Let's do number 20, just so I can see it right now, so I'm going out of order. X to the fourth minus 3x squared minus 4. And it looks like, you kind of see it, menu 5, 1. Solution of 2, negative 2. So x equals 2, x equals negative 2. And the last one there, oops. Okay, x to the fourth minus x to the third minus 5x squared minus x minus 6. Wow, these are just easy, right? Menu 5, 1, negative 2. Oops. And it looks like, let's just see, and 3, negative 2 and 3. Okay, so x equals negative 2 and x equals 3. That's all it said, just find the rational zeros. Use Pascal. If it crosses like a number like 2.587, you're like, that's not rational. Because it's probably a rounded number on there. use Pascal's triangle to expand the binomial. So first you have to have Pascal's triangle available. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You're adding up the two terms above it to get the next term. So 1 plus 4 is 5, 4 plus 6 is 10, 4 plus 6 is 10, 4 plus 1 is 5, and 1. Let's see, third power means fourth row, 1, 2, 3, 4. So I'm using this 1, 3, 3, 1. So 1, 3, 3, 1. First one to the highest power, so x to the third, x squared, x to the first, x. Last one starts on the back end, so y to the third, y squared, y to the first, and then constant. And we pretty much have it. We don't have to simplify that much at all. So this one is fourth power, so I need the fifth row. So 1, 2, 3, 4, 5, 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. Okay, 2x is being put to the fourth power, so 2x to the fourth, quantity 2x to the third, quantity 2x to the second, and quantity 2x. Last one starts with the last term, y to the fourth, y to the third, y to the second, y to the first. Pluses on all these. Okay. So this simplifies 2 to the fourth is 16, so this is 16x to the fourth. 2 to the third is 8. 8 times 4 is 32, so plus 32y. 2 squared is 4. 4 times 6 is 24. 2 to the third is 8. 4 times 8 is 32. And then plus y to the fourth. What's the third term? So really all I need is the third term of this one. This might be our last term. So fifth power. So fifth power is sixth row. So 1, 2, 3, 4, 5, 6. So 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay, but the really crazy thing is all I really care about is this term right here. So I might kind of work all these, but I really only care about that term. So 3x would be, 3x to the fifth power, the highest power. This would be 3x to the fourth. I don't really care about that one. So this is the term I care about, 3x to the third power, and then 3x, we're done. Okay, last term, -2 to the fifth, -2 to the fourth. I don't care about those. This one, but being very careful. Okay, this one I care about. This one is -2 to the second. So this is the term I care about. So it's going to be 3x to the third. So this is 10 times 27x cubed times -2 squared, which is 4. So that's 4 times 27. You might need to get your calculator out here. I think I might know that. Okay, so 4 times 27 is 108. So we get 108x to the third. And that is the end of the review.